This tutorial is designed to show students how to calculate various measures of central tendency, distribution, and shape. The various measures we will be looking at show the mean, median, and mode, the range, variance, and standard deviation, and also the skewness and kurtosis. We'll walk through each of these using a sample data set and show how to calculate them. The data we will use is displayed here, where we have various categories. So we have category 0 to 9, 10 to 19, 20 to 29, 30 to 39, and 40 to 29. We have the frequency given as f, and we have the midpoint given as x. So starting with just this basic data, we will calculate all of the values which we've shown down here. The mean, median, and mode, standard deviation, and skewness and kurtosis. We'll be using the various formulas provided here. So the first thing we're going to start with is calculating the mean. In order to calculate the mean, we require two components. We require the sum of f times x and also n, which is the number of observations. So to calculate these, we will write out our data as such. We will then compute the first value we require, which is the sum of f times x. So in this instance, what we will do is take each f value, so for instance 3, 6, 19, 27, and 5, and multiply the midpoint, so each x value, 5, 14, 24, 34, and 44.5. We do this for the first value, and we have value of 13.5. So 3 times 4.5. Working on down, 6 times 14.5 gives 87. And we keep working on down in this way. So 46.5, 931, and 222. So calculation down along. We then sum these components together and get a value of 1720. Now this value here is our sum of f times x. So if we look back at our formula, we now have the top component of the line. The next component we need is n, the number of observations. N is simply the total number of frequencies that we have. In this example, that is 60. So we now have all the information we need to compute the mean. So the mean is equal to our sum of f times x, which is 1720, all over 60, our number of observations. When we calculate this out, we get 28.67. For ease of calculation, I'm going to round this up to 29. So we've calculated step 1, mean. The next thing to calculate is the median value. And before we calculate the median, what we have to find is where the middle value in our data set lies. So where the midpoint actually resides. So where does our midpoint lie? To find this, we calculate the cumulative frequency value. After 60 observations, we're looking for observation number 30, which is our middle value. So we look to see what our first frequency is, and our first frequency is 3. So we take 3 and subsequently total up along the frequency column as we go along. So the next cumulative frequency would be 3 plus 6. So 3 plus 6 gives us 9. The next cumulative frequency is 3 plus 6 plus 19. This gives us a value of 28. 28 plus 27 gives us 55. And finally, we get 60. Note that the cumulative frequency value of 60 will always equal the total number of observations that we have. Okay? So we have a cumulative value of 60. And what we now need to do is find where would 30 lie in this. So 30 lies below this category here, our category 55. So it lies, our midpoint lies somewhere between 30 and 39. So now, let's take a look again at our median value. We need the lowest possible value the median can take, which we've identified as being 30. We need n over 2 minus the sum of the frequency preceding the median all over the frequency in the median category times the class width. So, if we calculate our median following this formula, we get the lowest possible value it can be, 30, plus 60 over 2, so our n over 2, minus the frequency preceding it, which totals to 28, all over the frequency within the category, which is 27, multiplied by the class width, which is 9. And this gives us a median value, rounding up, of approximately 31. So we've now calculated our mean and median, and all that's left to calculate in our measures of central tendency is our mode. So what we need to identify first is the modal category. That is the category which possesses the most number of values. In this instance, it's the same category as our median category. So we look at our frequency table, we see that 27 is the highest number. So we note that our median category, again, lies in 30 to 39. So we can now calculate our median category using our formula. Our formula is applied where F1 is the frequency in the modal category, F2 is the frequency preceding the modal category, and F3 is the frequency after the modal category. All other values are as defined before. So let's calculate out our mode value. So the mode is equal to the lowest value it can take, which is 30, plus frequency in the modal category of 27, minus the frequency before that, which is 19, all over, again, F1 minus F2, plus F1, again, which is 27, minus F3, in this instance 5, multiplied by the class width, which is 9, giving us a modal value of approximately 32.4. So we've now calculated out all three of our measures of central tendency. We've calculated the mean, the median, and the mode. The next step then is to move on to our variance and standard deviation. Now note that for the variance, what we need to calculate is x minus x bar squared times f summed. So we're simply working through this top part of the formula here, where x is our midpoint and x bar is the actual mean that we calculated earlier. So let's return to our calculations and open up the category x minus x bar. We'll do this in steps. So our x is 4.5. Our x bar, or mean value that we calculated here, is 29. So the first value we get is 4.5 minus 29, which is approximately 4. I'm going to round to the nearest whole number. Next value down is minus 14, followed by minus 4, 6, and 16. So we now calculated x minus x bar. We then look at our formula and see what is the next step that we require. We note that the next step is to actually square this value. So we need another column, which is x minus x bar squared. So we calculate this out, and it's minus 24 squared gives us 584. Our next value is minus 14 squared, which is approximately 201. Working down, we then get 17, 39, and 251. We note that when we square values, the minus signs disappear. Following from this, we then need to multiply by f. So we have f times x minus x bar squared. So our first value is 584 multiplied by the frequency of 3, leaving us with 1752. Our next column down results in 1204. We then have 330, 919, and 1253. And we sum this column up to get a total of 5458. So we can now see that we have f times x minus x bar squared, and we have the summation of it, so 5485. We now look at the next partial formula we need, which is n minus 1, the number of observations minus 1. We've already noted our number of observations are 60, so we simply take 1 away from this. So let's work out our variance. So we have the top of our formula, which is 5458, all over 60 minus 1, resulting in an answer of approximately 92.5. So we've calculated out our variance. The next stage then is the standard deviation. Now if we look at our formula for the standard deviation, we can see that this part here, which is in the bracket, is identical to the variance. The only difference actually between the two formulas is that we have a square root sign for the standard deviation. So what we say is the standard deviation is given as the square root of the variance. So this makes the calculation quite straightforward, given that our standard deviation is equal to the square root of our variance, which is 92.5. So we simply calculate the square root, and we get a standard deviation of approximately 9.6. So we've now calculated our variance and our standard deviation. The final thing we have to calculate is our range. So the range is the most basic measure of dispersion, and essentially the range is the difference between the lowest possible value that the data can take, so in this case 0, 0 is their starting point, and the highest possible value the data can take, so in this instance 49. So the range is simply the difference between 49 and 0. So the range is 49. So we've now calculated all our measures of dispersion. We've calculated our variance, our standard deviation, and our range.